So we want to find the interval and radius of convergence of this power series. So we are going to use the ratio test, which we're interested when the limit as n goes to infinity of the absolute value of, we need the ratio of the n plus 1 to the nth term. So we take 5 to the n plus 1, x to the n plus 1, over n plus 1 to the third, and we want to divide that by the nth term, so we're going to multiply by the reciprocal of the nth term. So that'd be n to the third over 5 to the n x to the n. And we need to have that limit be less than 1 to have convergence. So now we're going to see what we could do to simplify. This is 5 to the n, 5 to the 1, so the 5 to the n part will cancel. This is x to the n, x to the 1, so the x to the n parts will cancel. Now let's go ahead and we could bring the 5 and the x out in front of the limit because they're not involved with it, but we need them inside of the absolute value, well, at least the x. I could have brought the 5 out, but we're okay this way too. And so now we have left here n to the third over n to the third plus 3n to the second plus 3n plus 1. Now I went ahead and I knew the binomial theorem, so I knew how to just write this out, but you could either multiply it out or you could just basically use some reasoning to say if I multiplied this out, the highest power would be an n to the third and then there would be lower powers. So if we were actually thinking of this limit and we multiplied everything by 1 over n to the third, we can see that, and we're still interested in when this is less than 1, we can see that all of these terms would go to 0 as n goes to infinity, and we would be left here with 1 over 1. So what we have is, we'll go ahead and put the 5 out in front, absolute value of x less than 1. So the absolute value of x less than 1/5. We actually have our radius of convergence then, that's going to be 1/5. We could express this then without the absolute value signs, and it would look like this. And so basically our interval of convergence is going to go from -1/5 to 1/5, but we don't know if we need to include the endpoints or not. So now we need to test the endpoints. So we're going to go back to our original here, and we're going to try -1/5 for the x, and so that would look like the sum. We have n equaling 1 to infinity of 5 to the n -1/5 to the n over n to the third. And what we could actually do here is we could take this -1 part and express it like this. That would make that a positive 1. Then if we combine these to the nth power, they would just be a 1. So we can just get rid of that because that would be 5 over 5 to the n. So it would be 1 to the n. So that part wouldn't change. And so we see we actually have an alternating series, but we also have this p series with p being 3 that is convergent, and so we know that this converges. So we do need to include the -1/5. Now if we tried the other end would be a positive 1/5, and the only thing different in working this is this wouldn't have been a -1 right here because we did the positive 1/5. So this actually wouldn't even be here, and we could combine these. And so this simplifies down to 1 over n to the third, which is a convergent p-series, and so we need to include that endpoint as well. So our interval of convergence is going to be from -1/5 to 1/5 inclusive of the n's.